Another video. So today I have something interesting. I have a 48 gigabyte 4090 sent in by someone who had purchased one from China. This card is a little bit interesting because it shows issues when you load it on comfyUI workloads. So when the card gets, what the customer had said is that when it goes over 24 gigabytes, it starts having issues. And I didn't believe him because I don't think that's how memory is partitioned when it uses the chip select clamshell mode. But lo and behold, it seems like comfyUI is the only thing that shows issues, because I could run this on Vulkan memtest on Windows and it is fine. Here on NVMT, it says all banks are fine. And that's only just because I had recently replaced a few memory modules. So when I initially received this card, it passes memtest Vulkan. I put it on comfyUI, I see an issue. I say, okay. Then I load it on NVMT, and this was a few days ago, and I saw a few memory modules that are pretty bad, and so I replaced those. Put them back on comfyUI, and it works fine. And I tested it overnight, and I issue the customer an invoice, and I send it back, and it's all good. Customer gets it, immediately starts having issues again. And so this is weird now, because I kind of validated the card. I, thermal cycled it, ran a bunch of WAN 2.2 workbenches, workloads, and then power cycled it, turned it off for a little bit, it went cold and everything. And then basically thought, okay, it's good, send it back to the customer sends it back to me because it's broken again. So this is kind of weird, because then when I received it, I saw a bunch of memory training issues on NVMT, which you don't see here because I had just replaced those modules. So modules D0 and D1 were showing issues. I replaced both sides of those. NVMT doesn't tell you which side of the chip select is having issues, so you just have to replace both of them and then figure out what to do with them later. So now it doesn't show issues on NVMT, so you think, okay, great, everything's fine. Well, the reason I started this video is because it's actually showing issues, but not on NVMT. It's just crashing as a device on NVIDIA SMI. Okay, so now I'm going to go to our session. I hope that's in focus. Then I'm going to start comfyUI. So here we have the card, and theoretically what happens is, so we're watching NVIDIA SMI right now. It updates every 2 seconds. When we start the workload on comfyUI, and now I'm going to load the WAN 2.2 model. It started it. So it's up to a few hundred watts. The card seems like it's running, but it just dropped to 57 watts. So at this point, it should be running, but it's kind of stopped. So this is the pattern of the issue that I've been seeing. It seems to have loaded 18 gigabytes of models and then stopped at that point. And now, is it even updating? So it looks like we can't even call NVIDIA SMI because we have the timestamp. It's stalled. Oh, and that now my session's frozen. We can see that the program that I have monitoring NVIDIA SMI has also stalled out. So what happens typically after this point is that it comes back after a few minutes, and then it shows that the GPU has fallen off the bus with some kind of memory issues. Here we see after a few minutes the card comes back with the error symbols, and typically it's going to ask for it to be reset. So now I'm going to take the card and we're going to put it on a Windows benchmark. This is the interesting part that made me want to do this showcase, because I think I know what's happening here. As we see here, the GPU is about to give us a video signal. The thing that I'm interested in here is the GPU load and memory used, and then memory controller load is also interesting. So now I'm going to load Vulkan memtest, and this is basically a program to test the bandwidth of the memory. And so we've used 46 of the 48 gigabytes. It's loaded 90 well, it's loading 100% of the memory controller load. 93% GPU load, so we're pulling a lot of watts right now, over 300 watts. This isn't a full like firm arc load, but this is really stressing the memory controller. And I'm gonna run this. I'm gonna see how long it goes for without any issues. Okay, so here we have the card just after 10 minutes, and it's operating fine without any issues. You know, GPU load 93%, memory controller load 100%. No errors are coming back. It's loading at full speed, 850 gigabytes per second while under load. Temperatures are within spec. All of the memory, 46 gigs, are being used without any issues. So this is kind of an interesting card because it's passing a certain type of workbench workload, but it's not passing another, and it has an issue specifically going over 24 gigs on comfyUI. So this is something I've not really run into, and this isn't a card that I've made myself. What I noticed is that when this came from China, all the memory modules were completely donor, so they were imported from another, you know, bunch of cards, and they're presumably tested. So the one thing I did see on this card was that when I was reworking it, replacing what I thought were the bad memory modules, is that everything was applied with lead-free solder. Lead-free solder has a higher melting point and a higher brittle factor, so it's more susceptible to solder ball cracks. And this is maybe potentially why I thought this would be an interesting video, to showcase a unique failure point. It's either the guy is totally screwed and the core is dead, or there's a cracked solder ball somewhere in a very unique spot that causes issues over 24 gigabytes. So that's what I'm going to do next. I'm going to basically reball the core. I'm going to take it off, and we're going to see if that's the issue. Okay guys, so here we've taken off the core and I prepared it, cleaned up the pads, and everything looks fine so far. So I'm going to put the core back on and we're going to see if those issues persist that we've seen before, where over 24 gigs causes issues. I'm thinking another thing that could be causing problems is related to the circuit board used. I've done over 150 of these upgrades, and yet I have not seen a circuit board failure causing any issues. But this is a generation, I believe it's 1 or 2, I think it's 1 PCB, and there's a chance that something on the memory MOSFET side is crashing out whenever it goes over a certain power threshold. But I don't know why we want to see that on Vulkan memtest. So we're just gonna attach back on the core. You know, I say that, but I feel like the right way to do this is I don't want to overwork the core too much. So if this goes on and then it shows the same issues, I don't want to have to take it back off and then put it on a new PCB to test the Gen 3 PCB. So I think at this point, I can actually take it one step further. Though this repair is not really going to be cost effective anymore regarding my time or parts used on it, but I want to see what the issue is. So I want to see if I could isolate it to just the core being the problem versus some kind of memory issue. I'm wondering how I would do that. Okay, I'm going to think about it. It's insanely noisy in my workshop. I've got multiple things going, cards testing, machines on, fume extractors. So essentially this card, my running theory is that there's something possibly either wrong with the circuit board or one of the memory modules involving the chip select function, where it can address either the front or rear side memory module, because we see an issue when the card goes over 24 gigabytes used on specifically comfyUI WAN 2.2 workloads. I didn't dig into exactly what other workloads would crash it, but I saw on Vulkan on Windows that it didn't crash it. Maybe it's the CUDA version, but I don't know. I don't think the CUDA software cares about how to use these cards. It's most likely something with the VBIOS or PCB or one of the ways the memory chips are soldered. So what I have here is a board that I had ready for another conversion, and so this has known good memory and known good donor memory, and one of these cores was going to go on it. But before I do that, I'm going to quickly put solder on this core that came from the card that is having those issues over 24 gigs, but it's fine on Windows for some reason. So I'm going to solder it to this board and then see if those issues persist on comfyUI. Okay, so the card is cooled off a little bit. Now it is time to put it on a circuit board, or put it on a cooler. Okay, as we can see, it's hard to see, that's better. As you can see, the card is tested 5 minutes of the Vulkan memtest, and it's past testing. So now I'm going to put the card on the workbench, which there's currently a card right here running right now. But I'm going to take that card off and put this card on, and we're going to test if this card crashes like it used to under the comfyUI workload. Basically, this is only the old core that was having issues on comfyUI. And so if the issue is related to the core, any kind of memory controller issue or any issue with the chip select function, then it will show up on this card with the brand new PCB and brand new memory. Okay, so we've got the card plugged in. It's powered on. Here's the SSH session for that. And now I'm going to start the card. So we're loading the comfyUI front end right now, and I'm going to go on the main computer and start the workload for that one. Okay, so we've just loaded the WAN 2.2 model, and I want to see the memory go up 18, 20, 29. Okay, so here's the card after about 20 minutes of running. Actually, no, 17 minutes of running, and it's not failed yet. So this is consistent with how it didn't fail before after I fixed it, but this time we kind of isolated that the core looks good. If the issue is going to be the core after another shipment back to the customer, then there's not much we can do. But now we have the memory modules and the circuit board separately. I'm not really satisfied with this ending though, so what I'm going to do is prepare this to ship back to the customer. The customer gets a card back with known good memory modules and a good circuit board. Just to get the flux off and make this like it came from the fab, we're going to put it into some cleaning bath with the cleaning solution and just let it rip. So here's the original circuit board that came with the faulty card originally, and I'm assuming the issue is related to one of these memory modules. So we're gonna take off each of the memory modules. There's 24 of them. Oh, and they're attached with lead-free solder, so that could be pointing to one of the issues that we're seeing here, possibly related to a bad solder joint through thermal cycling. Okay guys, here's that circuit board with that other card, with the memory transplanted onto a new circuit board with a new core, and the memory's not showing any issues for about 30 minutes of memory testing. So now we're going to put it on comfyUI. Okay guys, pardon the noise, the fan is going at full blast, but here we have that card running for about 22 minutes. It's running the comfyUI workloads. That had issues previously where if it goes over 24 gigs it would have an issue, but now it's looking like the card is working without any problems. This is more than likely what it was with a solder ball issue, because the memory modules themselves had lead-free solder under them. So I put on all the memory modules onto a new PCB with a completely new core from another donor card, and the card works now, and it's running comfyUI, the workload. I'd say an interesting fault I've not seen before, where a cracked solder ball or a bad BJ connection because of the solder was on one of the chip select pins. So I think that's what caused the issue with going over 24 gigabytes. So this card is all good and done now. It's going to test for another few days.